Okay, and now finally, after understanding, kind of making my progress from anonymous methods, and now that I finally have been learning and understanding the lambdas, I think once you learn them, they're pretty straightforward. It's just that initial learning curve. They're confusing if you don't know what lies behind them. So since I've seen transition from where the delegate keyword is used when we're uh, wiring an event here, and now this being an anonymous method, now going from anonymous method to lambda expression is pretty straightforward. Another very confusing thing is that I always thought that this is some kind of operator that actually does something kind of like a math operator. But indeed, I would really call this just the compiler operator. This is kind of like telling compiler to do a lot of magic behind the scenes. So this is the anonymous method for anonymous function. We use this delegate keyword, and then anonymous method being the method that doesn't have a body, and since there's a one line of code, we can put it here without curly braces, and then also note semicolon at the end. If there are multiple, we have to put this, and then no return type is necessary. If this was returning something, we wouldn't have to put it here. It would automatically know. If this was like a integer or something other than a void. We don't have to specify the types because all this is actually something already exists. Delegate already has to exist one way or the other. You know, which syntax we use to create it doesn't matter, but even if the syntax is the one that doesn't explicitly create a delegate, if we don't do it in code, if we use the other way of doing it, syntax like a delegate of, compiler still knows the types. So we don't have to repeat them here using this lambda expression separator. It's all done with the compiler. And then another cool part here is using it to kind of see how it's used with the delegate itself. So here we have a delegate, and we want to instantiate it like we did in the beginning. So I create new delegate, and I give it a function name. Here's our function a plus b, and then actually run it just like I would any other method and assign it to the result here, and I send a couple of numbers. So here we have to instantiate it and create a method. All of this can be done using lambda expressions to where we just say a and b. See, it's already there, so compiler knows what they are, the integers. And then lambda expression, and we just send the body. There's no need for return, just a plus b, and it returns it. And then we go ahead and run it here, run the method, and we get the same result. So we don't have to write a method or instantiate it when we use lambda expression. So it's like a pretty good shortcut. So a quick example in the code here is we have this anonymous method right here, delegate. Before it was an anonymous method, I still have it greened out here. We use this another shortcut that actually gives us this, and then we know that this guy right here in the background is this syntax of creating a delegate without writing the actual delegate, which is this right here. So it's like a big progression of how the things decrease in how we reduce syntax and rely more on compiler to do all this for us. But if you don't understand this, it's hard to start somewhere looking at the Lambda expression when you have no idea anything about the delegates, what they are, how, because a lot of things are hidden. It's possible to understand it. So this reverse way of doing it was really good for me to finally understand it. And so we came to this syntax to where our word perform method is in line, just using this delegate keyword here to remind us it's a delegate that's behind it. And now Lambda expression, we don't even need to use the delegate keyword. We don't have to use the type because compiler knows we don't have to write a whole word of, we can just write it shorter, although we can keep sender. So this is all we need here. Then Lambda expression. Now we're telling something to compiler, and this is only one line of code, so we don't even need these. We just gotta, we can put it here, we can leave it down underneath, but so we rewrote effectively the anonymous method using the delegate keyword into the Lambda expression inline method, which kind of translates back to shorthand right here with the actual method. Longer, confusing because it's repeating what we have here. And then here we have this syntax that we don't have to write a delegate, and then if you wrote a delegate we have a different syntax right here. So that's basically down to the bottom, got to the bottom of using the delegates. So I mean using the delegates, events, event handlers, and finally working with Lambda expressions. It's all connected. I understand it all pretty well now, so that's great. And another thing to mention here, if obviously there was more than one line of code, we would have to use curly braces and put them here, and then if you wanted to reuse the method by something else, you would always want to write a method. We wouldn't really want it inline.